Hello everyone. So today's topic is fatigue, and we'll be discussing about fatigue and how fatigue works. Actually, what happens is that the most failure or most designed to fall in general work is due to fatigue of materials. And why it happens, there are a lot of reasons because we cannot encounter dynamic load in a proper way, or the static load is more or it is working where it is getting converted dynamic load due to some factors. So there may be lots of reasons. So we have to encounter everything. So the thing is that let us learn about fatigue, what happens and what not. So what is the fatigue, as we say, that when it completes its normal, I mean its number of cycles is how many days it will work and what not. After that, it cannot go anymore. For example, you can use a bike, or you can ask a car to run for 15 years. Government doesn't allow more than that. But after that, they ask for fitness certificate. Why? Because there's a fatigue cycle limitations. Because for the safety of the people. Next is our variable amplitude loading for this level of fatigue. That means there how you are loading, how is it is being loaded. Is it been extensively loaded, or it has been loaded gradually, or it has been loaded regularly? So that's the difference. Fatigue cumulated to an engineering element because it's a very much important for engineering perspective. Next. Next is our loading conditions, type of load, what is the stress, how is load is given, and what are the minimum load, what is the minimum load, what the approx load it goes to it, stress concentration. That means what is the sharpness and everything, the stress concentration may appear there, and the surface finish because surface finish leads to a hardness. Hardness leads to crack. If there is the hardness is maximum, the crack will be surface crack will be less, and then chances that the crack will propagate also less. Material like thermal history, the grain size, or is that been what are the heat treatment has been done, and what's it not, and what are the materials being used. So that what we discuss. Environmental conditions. Environmental conditions we have like temperature. What temperature it runs? Is it corrosive like it's near to sea or not? So that's all conditions we go through it. Next is our loading cycles. As you can see, there are three types of loading cycles. Okay, this is the one of the most worst one, random, and this is a repeated one, or you can say that this is the right one. This what we do standard loading cycle. That's where you can load, unload, and there is the maximum here in this graph. You can see this is positive. The more positive load you have, more positive stress you have, the lesser lesser chance to get fatigue is there. The maximum you get the negative load, you have a chance. Now here comes the point. When there is a zero stress, you cannot say that it is actually zero. It may be a fatigue sign. Okay, so like here, as it is transferring from positive to negative, there is a chance where it can be negative. So that's there is a negative impact. Like there may be a fatigue also. That happens because you are stretching something and you release it. You are asking them to again to get compressed. So what happens is that there is a chances to get this things. So it is a this type of loading is casual, and this correct because positive and negative curves are the same peak or same amplitude. It's correct. The positive is maximum, negative is less. Okay, okay, fine. That's not an issue. But this is very random. That means somewhat is higher, less, and this is completely fluctuating. That is, fluctuations are maximum. When the maximum fluctuations, there is a chance of breaking. But fluctuation is a general thing, and it should be in a regular way, or it should be encountered in a proper manner. If it is not done, you are in a danger. Now there's a no mean stress, that is 0 0 0. That means that means it is positive, negative, positive, negative, tensile, compressive, tensile, compressive. Fine, that's it. Mean stress reduce the range. That means the mean stress are higher, and the I mean you can see the compressive load is very low regarding to tensile load. So it's good enough. Next is our stress amplitude versus mean. That is done by Goodman relations. Goodman relations says that if you load a material, there are load a material from fatigue to ultimate load, so you can reduce in this way. That means if you load a material to a maximum of ultimate load, and how you can get a relation. That is in hyperbolic equations like sigma A by sigma F plus sigma M by sigma M. It seems to be hyperbolic equations, or you can say straight line curve equations. So from where we can find out what can be the stress. This is the applied load or allowable load. This is the fatigue load and what material will fail. This is the mean load. That is what we have seen in the earlier. That is the graph. The graph, and here is the ultimate load. That depends on the material to material. Next is our example, Goodman. So you could see that what is the maximum and what is minimum that will be applied. So what happens is that you can find out by Goodman diagram what is the maximum load you can give and what the minimum load you can apply. So that actually help us to understand. Okay, fine. We could this is what is the maximum one and what is the minimum. It is used where fatigue is necessary, but controlled fatigue is necessary because we are talking about ultimate load. But here comes one point. If you want complete safety, you will not go for ultimate one. You go for uh, your yield stress, where it is under your your uh, elastic zone. Now it is explained by Soderbergh and Soderbergh diagram. But in Goodman diagram, we actually deal with the ultimate loads to get whether there is chances to break or not. That actually gives us a broad explanation because this point may be uh, this point may be your your ultimate load zone only, under ultimate load zone, maybe not, I don't know. I'm just telling them. So what happens is that if you get this opportunity or the broad spectrum, a Goodman diagram gives a broad spectrum to understand where it can break. So you have that envelope to rectify. Even you have that envelope rectify. So you could shift that car by using better material, by using good material, good design that could help you out. Next is a very important thing. This is SN curve. What is the total about? This is the main thing which comes. Now you are applying stress. You need to know at what time it will break. You cannot say that it will break right now. At this stress, it will break right now with other stress. So it is not easy to say. So what you need to know that number of cycles can be calculated in a way. You say that log log of stress versus log of number of cycles. Now, what is log? Why log? Because number of cycles can be, as you can see, 10 to the power 1. That is 100, 10, 100, 1000, lakhs, and it can go for lakhs, CRs, that is crores, and that could also, that is numbers you cannot plot it. So what we can do, we just making a shortcut, we use your number of cycles. Okay, and we also put the stress in a in logarithmic zone where we put in 0 to 1 ratio. So or it may be 2 3. That means it would be a small number and you can denote it. So what happens is that the number says that if you apply if you want to break an object, if your object goes for fatigue in lower cycle, it will have maximum load. Whereas after a certain number of cycle, this load, load will come in constant. That means it has been broken. But as the time goes, as the number of cycle increases, the stress goes down. As the initially the stress was 0.8, and at the final before fatigue it is 0.4. That means as the number of cycles starts from 100 and it ends up at near about 10 to the power 4, near in between 10 to the power 4 and 10 to the power 5. So it breaks over there. So you will understand that if the stress is lower at before 10 to the power 5 and the stress is higher at 10 to the power 1. So that is what I mean. That number of cycles, as you increase the number of cycles, the number of the stress goes down. If the number of cycle is at lower number of cycles, the stress is higher. Okay. Next, minus rules, what we do is that we find out if there are a number of elements of there, and we have to find out what is the stress and how it works. So what we can do is we can do that is the number of repetitions applied. That means nothing but the stress and number of failure. How many times it will fail? That means how many times we have applied force or load, and how many times it failure. It should not. It should be greater than equals to one. If it is, because it will fail for one time also. It can. It not happen. It will not happen. It will not fail for one. That's why it is given one. So after that, we can calculate the minus rule. That is a minus rule. That is just for your knowledge. The example for minus rule, that you can see that stress at 3 ksi, the number of cycles is 300, but the number of fatigue cycles is 10,000. But at 5, and the number of cycles comes down to 50, and number of fatigue it goes to 500. That means the graph goes down by one by one. That's what I was talking about. That you have to go for minus cycles. Also, minus cycles you have to go to, and you have to understand how the uh, how fatigue works. It is an unexplored area, and it has been explored. It has been explored, getting explored every day by day. Okay, this is what we have. It is shown. As you can see, that number of people, and it will down. It will, as if the stress is number of 5. If the stress is at a magnitude of 5, this will break at this element can break at your uh, 500 cycle. If it is a if the stress cycle is 3, it will break at near about 900. So this is what we are talking about. Okay. This is what we are talking, that if it is number, it is greater than 1, since you can see 900 divided by 10,000, okay, it is greater than it is less than 1, okay, fine. Then 19% chances of fatigue life. That means 81% you can use it. Fine. So this is how we do the beam test or fatigue test. So where you can get the all the data, and we can use over there in preparing our graph.